Now we will be solving probability questions using combinatorics. Probability with combinatorics. And just a reminder, combinatorics is the way of choosing or counting numbers, and there are two kinds of combinatorics, or permutations and combinations that we looked at. So using these, we will be solving probability questions. So in a classroom of 10 students, there are 6 boys and 4 girls. Now I want to pick 5 students. Randomly. What would the probability be? What would the probability be of me picking 3 boys and 2 girls? 3 boys and 2 girls. Before we dive into this problem, let's kind of outline what we need to do to find this probability. So to find the probability of anything, we need to have the total possibilities or the total possible events, and we want the one event, the wanted event. Okay, so our wanted event for this part is 3 boys and 2 girls. Let's try and find the total possibility first. So the total possibility is, we have a total of 10 students, and we are picking 5 students from this group of 10 students. So we want to know how many possible ways of picking 5 students are there from a group of 10 students. And first of all, let's see if order matters here. If I chose student A, B, C, D, and E, is that the same thing as choosing student C, A, D, B, E? I'm not really assigning any places to the order that I'm choosing them. So it doesn't matter in which order I choose them. I chose 5 students here, and I chose 5 students here, and those 5 students happen to be the same 5 students. So the order doesn't really matter here. I'm just choosing 5 students from a group of 10 students. So in this case, we will be using the combination. Right, we're using combination. And the way to choose 5 students from a group of 10 students would be this. This can also be written like this. I think this way is much more common. So this means I'm choosing 5 students out of 10, and this can be read as 10 choose 5. So this would be our denominator. That's the total possible way of choosing 5 students from a group of 10 students. So that's our denominator. 10 choose 5. This is the total possible way of choosing 5 students. And the wanted event on the top, more specifically, our wanted event is 3 boys and 2 girls, right? And we want to know how many different ways of choosing 3 boys and 2 girls there are. Well, we can kind of divide this into 2 groups, and we can consider the boy part and then the girl part. So for the boy part, we can consider how many ways are there of choosing 3 boys from a group of 6 boys. If we have 6 boys, how many ways are there of choosing 3 boys? And again, the order doesn't really matter. We're just choosing 3 boys. We're not really assigning them anything. The order in which you pick them doesn't matter. So this also would be a combination, and this would be out of 6 students, I am choosing 3. or out of 6 boys, I am choosing 3 boys. So this part of choosing 3 boys would be this. How about choosing 2 girls? We have 4 girls in total. And again, the order doesn't really matter. We want to know how many different ways there are of choosing 2 girls from a group of 4 girls. So our combined case of 3 boys and 2 girls would be a combination of these 2 events. Choosing 3 boys out of a group of 6 boys and choosing 2 girls out of a group of 4 girls. Okay, so this would be our probability. Let's try it and find the actual value of our probability. So to simplify, this is what we're solving for. Oops. And at least let's see what we get. 6, you can obviously plug this in a calculator, but you need to be careful of how you put in the numbers. I'm just going to do them by hand just to show you how the calculation is done. So this part is the same thing as 6 factorial over 3 factorial times 6 minus 3 factorial. And that would be the same as 6 factorial over 3 factorial times 3 factorial. And if we expand the numerator, 4 times 3 times 2 times 1, and then we have 3 times 2 times 1, and then 3 times 2 times 1. The 3 factorial part from the numerator can be cancelled with one of the 3 factorials in the denominator. And you can see here that right there equals 6, so this can cancel with the 6 here. So we're just left with 5 times 4, right? So we just have 20 for this part. So this means there are 20 different ways of choosing 3 boys from a group of 6 boys. And if you are skeptical about that, you can list out all the different ways of choosing 3 boys from a group of 6 boys, and you'll find that there are 20 ways to do that. And let's try and find this part. So that would be 4 factorial over 2 factorial, and then 4 minus 2 factorial, which is also 2 factorial. So we have 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. The 2 factorial parts will cancel. The 2 here will cancel with the 4, leaving 2. So 2 times 3 will get 6. So this means there are 6 different ways. Let me actually circle these numbers so that it's easier to see them with all the other numbers around them. So there are 6 different ways of choosing 2 girls from a group of 4 girls. Okay, and then lastly, let's do the denominator. So 10, choose 5, that is 10 factorial over 5 factorial times 10 minus 5 factorial, which is also 5 factorial. Again, the 5 factorial will cancel with the 5 factorial on the top. So the top will be left with times 6, because the 5 part is going to cancel with the denominator. This part will cancel with one of our 5 factorial in the denominator. Denominator will have one of the other 5 factorials left. Okay, and then we can, to simplify the equation here, we can cancel a lot of things. This part right here, 3 times 2 times 1 is 6, right? So we can just cancel that with 6. And we can also cancel the 3. Oh, no, sorry, not the 3. The 4 with the 8. We cancel the 5 with the 10. Okay, so we get 2 times 9 times 2 times 7. That would be 36 times 7, which is going to equal 252. So 252 is the total number of ways of choosing 5 students from a group of 10 students. So to finalize our calculation here, we just need to do 20 times 6 on the numerator, which is 120, and then divide that by 252 in the denominator. And you'll get, 0.476 ... So that means you have about a 47 or 48% chance of picking 3 boys and 2 girls when you're choosing 5 students out of 10 students. So that's almost half. In almost half of the cases, you're going to be choosing 3 boys and 2 girls. And just to analyze this situation further, let me actually list all the possible ways of choosing boys and girls when you're choosing 5 students. So remember, we had 6 boys and 4 girls. And we can choose 5 people by choosing all 5 boys and no girls. That's one of the cases. We can also choose 4 boys and 1 girl. We can also choose 3 boys and 2 girls. We can also choose 2 boys and 3 girls. And we can also choose 1 boy and 4 girls. And if you look at the probabilities here, we actually found this probability right here, 3 boys and 2 girls. And that turned out to be 0.476. And if you do the same thing for these other cases, I've done the calculation in advance, you'll get these probabilities, 0.238 for these ones, and 0.0238 for these ones. And I've rounded these numbers. These aren't exact numbers, but you get the idea. And you'll notice some interesting patterns here. Okay, this seems to be the biggest probability. So this is the most likely outcome. About half of the time, it's going to be about 3 boys and 2 girls. About the other fourth of the time, it's going to be 4 boys and 1 girl, or 2 boys and 3 girls. And almost barely will it be 5 boys and no girls, or 1 boy and 4 girls. Okay, so as it goes to the extreme cases, the probability gets smaller. And also, if you add up all the probabilities here, then it's going to equal about 1. It actually should equal exactly 1 if I didn't round the probabilities, but since we've done some rounding here, this is going to equal about 1. Right? And also, you'll notice some patterns. Like these probabilities are the same. Why are they the same? And these are the same as well. Why are they the same? So think about those characteristics. You can think in your own time, why is choosing 4 boys and 1 girl the same, or it gives you the same probability as choosing 2 boys and 3 girls? Or why is choosing 5 boys and no girls gives you the same probability as choosing 1 boy and 4 girls? So think about these in your own time, and I hope that this problem familiarized you a little bit more on combinations as well as on probability.